So what we've done so far is find probabilities. If we have a normal distribution, we've said, okay, if I have a particular z or x value, let's say 1.5, I can find a probability, an area to the left, an area to the right, or an area between two numbers. But now, let's say I want to do the opposite. Let's say I start out with a probability, so maybe I know my area to the left of my z value is maybe 0.6, and I want to know what is that z value. So we kind of want to work backwards. And so we could try to use the tables and find the probability in the table and try to find whatever z-score would give that probability. We might have to estimate, but it sounds a little bit annoying, and we can actually do this in Excel. So when we were finding probabilities, we used norm.dist. Now, if we want to do the opposite, if we know a probability and want the z or the x, then instead of .dist, we're going to use .inv. So you can think of inv being like inverse, doing the opposite. And so if I use norm.inv, I'm going to plug in the probability or the area to the left of the thing that I'm looking for. And if I don't put the .s, then I'm going to need to tell Excel the mean and standard deviation for my distribution. And if I do put the .s, that means I'm dealing with a z value, a standard normal, and I don't have to tell Excel the mean and standard deviation. So if I look at exercise 19, it says to find z star so that the probability that I get a z that's at most z star is 0.61. So that means I'm looking for a z star that has an area of 0.61 to the left. So what it's telling me is that the probability that I get something to the left is 0.61. So this area to the left is 0.61, and I want to know what z star has that area to the left. So in Excel, I would do norm.s, since I have a standard normal, and then .inv, and I would plug in 0.61, that area to the left. So let's see what this is in Excel. So in Excel, I would do norm.s.inv, and it wants me to plug in the probability, the area to the left, which is 0.61, and so my z value is about 0.279. So this would be about 0.279, and I guess if they want 4 decimal places, this would be 93. And so this lets us find a z value if what we know to start with is an area. Now, before we move to the next problem, I just want to switch this up a little bit. Let's say that what they told us, instead of telling us the area to the left, let's say they told us that the area to the right of our z star, so I'm putting a greater than or equal to, let's say they told us that was 0.61. So that would mean that my z star has to be somewhere over here because the area to the right is 0.61. So they're telling me an area, they're telling me a probability, but they're not telling me the probability to the left. So if I want to find z star, I would still want to use norm.s.inv because they're telling me an area, but what I plug in has to be the area to the left. Well, the area to the left isn't 0.61, it would be 1 minus 0.61. And so earlier when we were finding areas, we had a 1 minus out front. Here it's inside because we have to plug in our area to the left inside the formula. In exercise 20, it tells us that the area in a certain interval is given to us. So it tells us if I have 0 in the middle and I go up to z star and down to minus z star, it gives us the area in that interval and asks us to find what z star is. Well, let's see, they're giving us an area, asking us to find a z, so we want to use norm.s.inv, and we have to figure out what our area to the left of that z star is. Well, it's not just the probability they give to us, that's just the area in the interval. The area to the left of our z star is all of this shaded region. So what we might want to do first is figure out the areas of these tails right here. And we know everything has to add up to 1. So if I do 1 minus 0.69, I would get 0.31. So the areas of these tails have to add up to 0.31. And if I want to find the area of one of those tails, I would need to divide by 2. So let's see, if I do 0.31 divided by 2, that should be 0.155. And you could check this in Excel or a calculator. You could do 0.31 divided by 2, and this should be what you get. So the area of each of these tails is 0.155. So the total area to the left of my z is 0.69 plus 0.155. And so if I do this in Excel, that should give me z star. Alternatively, if I had done norm.s.inv of just 0.155, if that's all I had plugged in, that would output negative z star. So that would be the negative of the number that I'm looking for. So if I wanted these two formulas to be equal, I would need to put a negative in front of the second one to flip the sign. Now let's take a look at exercise 21. This says a random variable follows a normal probability distribution, and our mean is 50, and our standard deviation is 20. And the first question is, what value of x represents the 75th percentile? So what that means is I have this curve that has 50 in the middle and a standard deviation of 20, and we want to know what x has 75% of things below it. So that's like saying the area to the left is 0.75. Well, they're giving me an area, so to find x, I would want to do norm.inv instead of .dist because they're giving me the area, and then I would plug in that area to the left and my mean and my standard deviation, and that would give me x. So here it says if we plug all that in, we would get about 63.49. So the x value of 63.49 has an area of 0.75 below it. Part B says find the value of x so that 40% probability lies below it. So that's really similar to what we just did. We would say, okay, I have an area of 0.4 to the left, and I want to know what x this is. So I would do norm.inv, since I'm given an area or a probability, and I would plug in that probability to the left along with my mean and standard deviation, and that would give me about 44.93. And this makes sense because in the middle we have 50, and so this seems reasonable. In part C, it says now find the x that represents the highest 10% of values. So what that means is the highest 10%, that means I want an area of 0.10 to the right of my x. So I do want to use norm.inv again, but the number I need to plug in should be the area to the right, or excuse me, to the left, and I've been given the area to the right. So to find the area to the left, I would do 1 minus 0.10, which is 0.9. So into my formula, I would plug in 0.9 and then the mean and standard deviation. And if we do this, we should get about 75.63. And so it's important to think about if we're given the area to the left or the right, and make sure that the thing we plug in really is the area to the left. Number 22, we'll get a little bit more practice with this and practice figuring out which formula we need when. So here it says the retirement age of professional athletes, we're going to assume that that age in a certain league is normally distributed, and our mean is 32.27 years, and the standard deviation is 3.62. And so part A wants us to find the probability that a randomly selected athlete's retirement age is at least 30.15. So at least means we're looking for an area to the right. So here we would do 1 minus norm dot, and we want to find a probability or an area, so we're going to use dot dist. And then we do 30.15, and then we would plug in our mean, our standard deviation, and true. And so I'll let you type all of that in and check your answer with the answers in the notes if you want to, and we'll just talk about how to set these up. So part B says find the probability that a randomly selected athlete's retirement age is between two numbers. So between 30.33 and 39.65. So here, again, I want to find a probability, and so I'm going to want to use norm.dist, and first I'll plug in the bigger number, and then the mean and the standard deviation, and true, and then we need to subtract the area to the left of the smaller number. So subtract norm.dist of 30.33. And then our mean and our standard deviation and true. In part C, it's not asking us to find a probability. It says find X star so that the probability that a randomly selected athlete's retirement age is at most X star years is 68%. So I have some X star, I don't know what it is, and they're telling me that the probability that something is at most that number, so the probability I get something smaller than that number, that probability is 0.68. So here, I know the probability and I want the X star, which means I would use norm.inv or inv instead of .dist. And I would plug in that area to the left and then plug in the mean and the standard deviation, and that would give me that X star. Now let's try D. So D might feel a little bit trickier. It says find the K so that the probability that a randomly selected athlete's retirement age is within K years of the mean, so that 32.27 is our mean, that probability is 42%. So if I draw a picture, in the middle, I have my mean, which is 32.27. What this is saying is if you add and subtract K from that mean, this should be symmetric. It doesn't look symmetric in my picture, but if I add and subtract K and go up and down by some K, and this probability is 0.42 or 42%, I want to know how far up and down I went to get 42% of the data. Well, before we worry about figuring out K, let's first just try to find one of these points. Let's maybe find this left one. So if I know something about the area and I want the X, then I'm going to want to use norm.inv, and I want to plug in the area to the left. Well, I have to figure out the area to the left. So let's see. The total area of the tails would be 1 minus 0.42, which is 0.58. So to get the area of each tail, I would do 0.58 divided by 2, which should be 0.29. So the area of each tail is 0.29. So the area to the left of that X that I'm looking for is 0.29. And then I would plug in my mean and my standard deviation, and that's all I need. So that's how I would get this X right here. So let's switch to Excel to see what this is. So in this problem, our mean is 32.27. Our standard deviation is 3.62. And we first want to find norm.inv of 0.29, and then we want to plug in our mean and our standard deviation. And this will give us that lower x value, that lower endpoint on our interval. But we didn't just want this number. We wanted to know k, and our k was how far down we went from the mean to get this number. So to find k, we would do our mean minus this value that we found. So this number right here would be our k. And if we wanted to round it to some number of decimals, we could do that in Excel and have Excel show fewer decimals. But this tells us that if we went up and down by about 2.003, so if we went up and down from our mean by about 2.003, then we would have 42% of the data. And so now I want you to take a look at this last exercise here, and you can try different versions of this last exercise and practice using all of these tools to answer similar questions in this different scenario.